Hi, everyone. So welcome to my talk. It's a resourceful talk about Android resources. I'm Vadim, and I'm working on the design tools team at Google in London. So over the last few months, I've been working quite a lot with resources, and I've been trying to understand how they work, how like the qualifier work, what you need to do in order to have like a correct application and everything. And we did some user study to understand how people were using resources. And something that came up quite often when people add resources like Drawable in their project is that they don't need to add multiple densities. The framework will generate for them. So basically, they were just putting a high version of their asset, and the framework would just downscale it. And this is true. Like if you just put a high density asset, the framework will downscale it. This has few drawbacks. It's CPU intensive. Downscaling from high density to a small density takes a while. You will lose some quality, you're downscaling, and you don't have any control over the details you want to show on the smaller version of your drawable. So I was looking at the Android developer website and see what actual density we would need to support. And it turned out that this is totally not up to date. If we look at, I was looking then on Google and Stack Overflow, and somebody was telling that in 2015 that XXX HDPI is an overkill, and we have no device like this. Well, they exist since 2000, probably 16. We have like the Galaxy S7, and now all the Pixel 3 XL is also high XXX density display, and the S10, the Samsung S10. So yeah, you need to support assets 4 times bigger than the medium density. So let's go back to downscaling and see what the framework will actually do with the resources. So this is not just an image, this is a screenshot of an image that I've taken on a Pixel 3. It looks nice, it's quite smooth. But now, if we let the framework downscale it, what we will see is this. So I don't know how well you can see, but we have like kind of a bigger version here. So we see that all our bubblegum balls have been totally aliased. And that's kind of the important part of the picture. So what you could do instead when you scale down manually, you could decide to crop it and to only scale the crop version. So this would appear on a low density display. So I've taken extreme example. This is going from a XX HDPI display from a low density display, and there is probably no more low density. But keep that in mind when you downscale your images. You might not want to downscale everything. And this is even more true for small ones like icons. So this is an example I took from the Simply.io website, where they say that designers should design at 1x. So you should first design your asset for a small density and then upscale them when you create them. So what we can see here is that the big asset has been downscaled, and because of the interlacing for when doing the downscale, the pixels have been merged together on the small one. And so we kind of are losing the sharpness of the icon. So what you should do instead is create multiple icons for smaller density and higher density. So here, the small one doesn't appear blurry at all, and the big one looks perfect too. And if we just scale down the small one on the top one, what we can see is that they don't actually match perfectly. The light blue icon has kind of smaller border, smaller space between the border and the plus icon. So I've taken some other example of what you can do. So this is a shutter icon, and on the top row you can see what this looks like on the device, and then we scale it up to see what it looks like at a bigger size. And you can see that the small one has bigger gaps. So that way, when you sit in a small screen, the gaps are still visible. And on the big one, we don't want to have like this ugly big gap, so they are smaller. So this is one way to improve your icon. The other way is to deal with the number of details that you're going to show on your icons. So you can see that the big microphone has many dots representing the grid, while the small one doesn't have any, because if you were to downscale the big one to the small one, all the grid points would be just merged together and can look like a very blurry gray area. So the thing is, if you actually create all this icon, and for the people who've been to the talk before, you know that you shouldn't, and you should use Vector-drawable, but I'm sure there is still JPEG and PNG in your projects. So what you can do is use WebP. So WebP is not that new. It's from 2014. And it's an image format that uses a new compression algorithm, which is also used in video, the X265 format. So this is one of the equivalent compression. And you have a lossless mode, so for PNG it's perfect. And if you use WebP instead of PNG, you might have WebP smaller by 26%. If you use the lossy version for image that you usually have as JPEG, you would earn, you gain as much as 34% smaller WebP. And within Android Studio, you just have to right-click on a JPEG or a PNG, and you can convert them. So here we're setting a size of 65% and keep the lossy encoding because it was a JPEG. And so yeah, you have many options, and you can press OK. Then you have this dialog that shows you the before and after, and in the middle, we barely see anything because that's the difference, that's the diff between the two images. And if you can't see, yeah, we can barely see, but at the bottom, we see that we are saving 50% of space using only a 65% lower quality, so 75%, sorry. So yeah, use WebP. Another way to, when you have many assets for many density, to have a smaller APK. This is important, especially if you want to target low-end devices, which are going to have lower density, which means also they're going to have lower storage, lower CPU. You can use splits or app bundles. So splits is already kind of old. What you do is, in your Gradle file, you define for which densities you will create an APK. So in that case, we have MDPI and HDPI. And what it will do is to create an APK for each of the resources. We also have the x86 because you can also specify which target architecture you want to generate the APK for. And on those APK, you will only have the resources that are targeted for the desired resource, desired configuration. The other and newer and better way to save this space using split APK is to use App Bundle. So App Bundle has been introduced at Google I/O last year, and it's a new format that kind of replaces the APK, and you would upload this format. So you have to kind of format have a special hierarchy within your project to generate an App Bundle. Then within Studio, you can generate App Bundle, and you upload the bundle to the Play Store. And at download time, the user will only download the configuration that they need. So that's pretty powerful, and you don't need to manually have to handle that. So I won't talk much about Vector-drawable because they talked about it right before. So if you want to know more about it, just go to the previous session on video and listen to the two kind of gods of Vector-drawable, Alex and Nick. And so they were telling Vector-drawable should be into any DPI folder. And when I look at the density, the qualifier that are available on Android, I'm kind of confused by the difference between any DPI and no DPI. So how many people here know the difference between any DPI and no DPI? No hands. So nobody knows the difference. Well, one. Congrats. So yeah, I looked into it, and to understand it, we're just going to look at all the different DPI that you can have. So any DPI is a scalable drawable that fits on any device density. So it's a Vector-drawable. There is no other, I don't think, or maybe 9 patches. Then you have the one you know, extra HDPI. So in that case, it's something that is 3 times bigger than a medium density bitmap. So you would put your PNG, WebP, or JPEG in it. Then we have the default one. The default one is considered to be medium DPI. So something that requires medium DPI, if it cannot find it in the -mdpi folder, we'll try to find it in drawable. The only issue with that is the resources in drawable won't be split using the split APK or the app bundle. So if you really want something only for MDPI, you should put it in the MDPI folder. And then finally, no DPI. So no DPI is something that won't be scaled at runtime. So I don't know, maybe you want to have something that is pixel perfect on the screen, so you should put it here. And if you put it in any other directory, that doesn't make any sense because the image has no density, is not density dependent, and there shouldn't be any other version on other folder. And if you do, well, it will just be ignored, the no DPI version. So the order you see here is kind of, if you take a modern device, like a Pixel 3 with an extra high density, it will look at this folder from top to bottom to find its resources. So any DPI, because it takes precedence over all other assets, and if you don't use AppCompat, it's only supported from version V21, you should put the V21 qualifier on it. So now, how that works in practice. So with that configuration here, if you have any device that is over or equal to API 21, it will feed from the drawable in any DPI v21. Anything lower will take the highest next density available. So an HDPI will feed onto the XX HDPI and downscale it. A low DPI, even though there is not many of them, will feed onto the drawable one because the drawable is considered as medium DPI. And then nobody would feed on no DPI because there shouldn't be any resource there if they are on the 3 first. The other question I ask myself is like, what is MIPMAP? And when you look around, MIPMAP is you put your app launcher in it and the rest goes to drawable. So who put MIPMAP, who used MIPMAP for other things than launcher icons? Yes, oh, one. I need to ask you why. So what is a MIPMAP? Because just to know what it is. So it comes from much in small space, and the map comes from bitmap. And it's used when you downscale. Instead of taking the highest density version, it will take anything that is below the closest to the target density and will scale down from this density. So if you happen to need a scaled image in your application, you can use a MIPMAP. And you don't have any, I would say, you don't have any confidence that the renderer will actually use a MIPMAP to downscale, but at least it gives the opportunity to do it. And the issue with MIPMAP is because they are supposed to be all used, they won't be split. So if you have a low DPI MIPMAP and you have an extra large density device, the low density will be there. All right, so with all those resources available, we end up in Android Studio with this kind of view, and it doesn't really give us much information on what's available. So imagine you're new into a project, you just see that you have to open each single file to understand what's there. So in Android Studio 3.4, we've introduced the resource manager, and Nick kind of told me the whoa effect because he told about it before. So what is the resource manager? It's a new tool which allows you to import, explore, and use your resources. And I've had some discussion before and some feedback that nobody can find it. So where it is, it's right below the project view here. So now you know, and you will find it. So let's take a little tour around what you can do with the resource manager. One of the main features that I felt was missing is batch importing resources. So I've exported some images from Sketch with the default export option that they provide for iOS and Android. And that's what you get. So if you export for Android, you get 4 folder, MHDPI to XX HDPI, too many X. Or if you export for iOS, you have the at2x.png version or at3x. But what you can do with the resource manager is just take all of that at once, and you drop it onto the resource manager. And they all will be grouped by name. If there is any suffix, like for iOS, it will be stripped down. If we recognize any path, any density indicator in the past, we will use it to know where you should put this drawable. And then you can see from the resource manager, if you double-click on one image, you will see all the different versions. So it's pretty useful to kind of have an overview of what you get. Next. Yeah. So for the density parsing I was talking about, this is what it would look like. So if you have the suffix add to x, it will transform to x HDPI. It will be the drawable in the right folder. The folder will be created for you. You don't have to do it manually in your Finder or your Explorer. Or if we recognize anywhere an Android qualifier in the past, it will be put in the right place. And as a reminder of what is the mapping between iOS and Android, 1x is the default one, is MDPI. 1.5 doesn't exist on iOS. And then the rest is 2 for x and 3 for XX. And you can read the last one because, again, too many x. What you can also do from when you import drawable is to reduce the qualifier that you get. So imagine that you have an email that is only for French. You set the local. You don't care the order of it. You just put it, press import, and then you go back to the resource manager. And when you open it, you can see that here the last one has the correct qualifiers, and the folder has been created for you. So no need to worry about that. SVG conversion. So, whoa, that's what Nick told me before. Yeah, you can batch import your SVG now. So you can also use the pop-up icon on the top. If you don't like drag and drop, you can rename also before importing. And then like fast forward, you import them. It creates Vector-drawable. So now if we double-clicked on a vector, open it. So if you double-click and there is only one version, it will open the file directly. You have your Vector-drawable that is created, and you can see it in the preview, and you have the proof on the left. It's not optimized yet. I would like to add the optimization while importing. That would be great. I'm going way too fast. So color preview is also kind of a really neat feature. When you have a color palette in your app and you might not know the exact color that you are looking for, you can use that to quickly skim through your colors and choose which one you want to use. And then there is an integration with the layout editor and with the XML. So if you have a drawable and you drag and drop it from the resource manager to the layout editor, it will create an image view. And you have the layout overview. So that's I really like that. So we are using the same render as for the preview. And when you have many layouts and you don't, I mean, imagine the use case where you are debugging an app, you have the phone, you see the layout that you need to edit, but you don't know exactly, you can't know the name of the file. So what you can do is open the resource manager, look at the layout, and you can skim through to find the matching layout. And ideally, you would have used sample data to, like here, to populate the images, so you don't have just a white screen on your layout. So if you here again, if you drag layout, it will create an include tag in your in the layout editor. And then I know some of you don't like to use the layout editor, so there is also an integration with the XML editor. So same as before, this is kind of a weird introduction, but it works. You can drag and drop onto an image view tag, and it will change the source of this image view. If you drag and drop onto an XML attribute, it will change the value of the attribute. So you can drag it on the background attribute, for example, and it will set the background drawable. And if you drag and drop the whole drawable onto an empty space, it will create an image view. So you don't have to type manually the whole thing. I just realized that this is my last slide, and I know I will be short, but not as short as that. So yeah, thank you. We're going to talk a little more about that and the data editor at I/O. And yeah, you can also send me messages on Twitter if you want. Thank you. So I'm going to risk it, I guess. Is there any question? Since we have time before the non-serious talk after. No question. Great. I was very afraid of doing questions. Thank you.